Welcome back everyone to the Hello World Kai. This is another episode of the Raycasting series, and in this video we are going to look at some problems in our pathfinding, and we are also going to look at some ways to fix them. So as far as our pathfinding is concerned, this is going to be our second last video with regards to pathfinding. In this video we are going to implement some of the problems which we will see in just a moment, and then in the next video we are going to implement some steering behaviors to prevent our enemies from getting stuck in corners and stuff. So we'll take a look at that too. So for now I'm going to go ahead and run make here, and to illustrate the problem I've actually created this new map here. So if I go ahead and go under editor, you can see that this map just has this has like a big room here, wooden room, and this has got like a single opening here which is one cell wide here, and it has got an opening in the back which is two cells wide. And if I go under our things mode, you can see we have got two things here. Now I have increased the size of the monster. By default our monster has actually a size of you can see that it has a size of 0.5 by default. So if I go here, you can see that this is actually a size of 1, and by the green line you can see this is actually larger than what the monster is supposed to be, but it does work. And the point is that we can see that this is working. So we can generate a path, and our monster will try to chase us, and the way the monster will try to chase us is that it will try to go through the shortest path, which is this opening at the top. Now the monster size is actually increased quite a bit. So if I go ahead and actually open up my game.cpp, what I'm doing is I'm taking where the monster is. So I'm actually just hardcoding the value here just for debugging. We are starting from our position of 8 and 3 on the X and Y, and we are going to the player's position, and we are basically having we are finding a path in our render function, and what we do is we just draw this path for debugging purposes. So if we are in the game mode, then we set our rectangle's color to blue, thickness to 0, we set its size to this, and then set the origin at 0 0, and then we go over and draw it, and we draw it basically with the correct position, and basically draw a blue box is where our enemy is supposed to go. So if I go under 2D mode and I go here, you can see that this does illustrate pretty well the path that our enemy will try to take. The enemy will try to go through the shortest opening. However, since our enemy has a size of 1, that means that the enemy is actually a bit too large to actually go through. So if I shoot, you can see that the enemy tries to come here, but the enemy actually can't move because this opening is not wide enough for the enemy, and basically the enemy thinks that it cannot find a path towards us. It does think that it can find a path through here, but that path doesn't work, even though there is a wider opening back there that the enemy could use to reach us still. So we are basically not taking size into account as far as our pathfinding goes, and that's something that we need to do. If the size is correct, if I go for example here, you can see that the enemy is still able to find the correct path here. So you can see that he's able to get the correct path here, and that works. And there is some problems which we'll see in the next video, but the thing is that our enemy can't find the path through here. So how are we going to actually fix this? Well, to fix this we are going to have to take our size into account when doing our pathfinding. So I'm going to open up pathfinder.h here, and we are going to change our function. So we are going to change this to also take an integer. Actually this is going to take a float size, but for our BFS we need the size in like map grid cells, so we are going to take that as an integer. And we are going to go ahead and open up pathfinder.cpp, and in game when we are actually doing this, we are going to specify our size as 1, which is the size of the enemy. And in thing.cpp, when we are doing for our enemy, we are going to just use our thing.size here for the actual size of the pathfinding. And you can see we have got our size here as a float, and what we do is we when doing our BFS, we are going to change the constructor here to be correct. And so we are going to take the path here, and when we are calling our BFS function, we are going to provide it with our size. Now the way we will do that is that we will do std seal on our size to basically make sure, basically get the space in grid cells that the enemy can stand on. So for example, we are going to pass our size here, and we are going to just add a small value, because the way our path, where our collision detection is organized, an enemy of size exactly 1 will not be able to pass through one grid cell. So we need to add a small bit of value to account for that. And basically this means that, for example, if an enemy has a size of 1.5, the grid size will be 2, because that enemy cannot stand in one cell, so it needs at least 2 cells to stand. So the way we will do this is when we are doing our BFS, we are going to actually go ahead and we are going to basically make a lambda here, which is can stand. We can just call it can stand to find out if our enemy can stand in a particular node, and this lambda will basically have I'm this here, and for the arguments this will basically take a node here, which I'm going to just call node, and we're going to go ahead and get the xy of this node, and then we're going to check if we can actually stand here. For now I'm going to just return true for all of this, but the way we'll do this is that after getting our next node in the generals, we are going to check if node can stand, and if we cannot stand in our next node, then we're going to just continue and leave that node. So we just need to change this can stand function to actually return the correct value. So basically inside of this lambda we are going to have to verify if we can stand both, if you've got space to stand either on the left or the right of this node, and similarly on the top and bottom, and if you've got space then obviously we can stand there, otherwise we cannot. So the way we'll do this is we're going to just add a capture here, and then what I'm going to do is I'm going to actually create another lambda, and this will be check axis, and we are going to call it we're going to say int we're going to say positive here, or we can make this actually a bool, and this will represent whether we want to check in the positive or the negative direction, and we are also going to have a bool x-axis and then a bool positive. And what we'll do is we will go ahead and make this a lambda basically. So we're going to make this a lambda, and then what we'll do is we are going to go ahead and make a for loop. We will start at 0 and go up till our size value that we have got, and what we will do is we will take our we are going to basically go ahead and check if map dot get, well, we are going to actually have to take the map as an argument, but instead of taking it as an argument we are going to actually have a reference to a map. So we are going to have a reference to our map stored in the Pathfinder, because that would just simplify things a lot, and then in the constructor we are going to assign the reference to the map like that. Yeah, so basically that's what assign it. And now what we can do is we can, when we are checking the axis, we can go from 0 to that size, and then we can go ahead and check if not map dot get map cell. So we are going to check if our map dot get map cell is that cell is basically empty. So we are going to go ahead and use our x. For the x value we are going to just have to, actually we are going to have to take a node here too. So we are going to just take an int x and an int y. So what we are going to do is we are going to check if our x-axis is true, then we are going to check if our x plus I, and when we are doing our plus I, we are actually going to have to check if our positive value is true. So we are going to check if our positive is true. If it is, then we are going to check I, otherwise we are going to check negative I, like that. And similarly for the y, we are going to basically we are going to, otherwise if our x-axis is not true, by the way, we are going to just use the x value without any other thing. So we are going to go ahead and get this whole thing, and we are going to copy that, and then we are going to paste this here again. And for this we are going to invert our x-axis check and change this to the y-axis like that, and then we are going to go ahead and basically pass it another, we are going to pass it map layer walls here, because we want to check the walls, and this basically will check it on both axes and both directions depending on the arguments. And what we want to do is if any of this when we check our cell, if the cell is occupied, then that means that this is obviously not true. So we want to actually change this. If it is occupied, then what we want to do is we want to return false, because that means that obviously it's wrong. And if we did not return false, then that means that we did not find any occupied map cell, so we can return true. And now what we are going to do is we are going to basically get our x positive, and we are going to get that by checking our axis on x and y, and we are going to tell that to be true while this is going to be false. And then we are going to go ahead and use similarly but for negative x, and we are going to basically do the same thing, but for the positive value we will pass in, actually we are going to pass in false here and true when we are checking the positive one. And similarly we are going to do this for the y like that. So we are going to change this for the y, and we are going to change this as well to be false, because now we are no longer having x-axis here. And then when we are returning, if we want to check if we've found a place on either side on both axes, so either x positive or x negative was true, and y positive or y negative was true. If one of these was false, so for example on one axis either y or x, both the positive and negative was false, that means that there is no place to stand there. Now if I go ahead and actually run make here, what you should be able to see is that now we are able to, if I go here and I go here, you can see that the enemy is now finding the path correctly, and the enemy is no longer trying to go through this place here. And of course, if I were to pass in a smaller size, so when we are doing here, if I were to pass in 0.9 instead, then the enemy will find the correct path right straight down, and it won't actually go through the other path. So we can do this, and you could technically also do this when constructing a graph, but that means we'll need to construct a different graph for each size of enemy, which would just complicate things. So what we do is we just construct a single graph, and then we change this based on our current enemy whenever we are doing the pathfinding. So you can see that the enemy now does not try to go through the top opening, but instead tries to go through the bottom opening at all times. Now, of course, if I actually try to get the enemy to chase me, what you would see is that that actually does not work. That is because the enemy goes through here, here, and here, but then when the enemy starts to pass through here, the enemy actually fails to go to the next cell. And the reason behind that is because we are basically trying to move linearly from the center of one cell to the center of another cell, and that is not working quite well, especially with larger sizes. So the enemy actually gets stuck in the corner, and that is not quite ideal. That's not really what we want. So we don't want our enemy to get stuck in the corner. We would have to implement some steering behaviors, and that is something we'll take a look at in the next video. For this video, there is a small thing that I would like to take a look at. So if I actually go ahead and actually run this, for example, and I go under the editor, what I'm going to do is I'm going to go ahead and change to this, and I'm going to block the path from here, and then I'm going to go under things mode. I'm going to select the enemy, and I'm going to change the enemy to face the player instead. And what you would see is that technically our enemy should not see the player, since there is a blocking in the way. But if I reload the map, what you can see is that the enemy does see the player, or does it? Well, if I actually start game mode, yeah, you can see that the enemy sees the player and starts chasing, which is not really what we want. The enemy should not be able to see the player through walls, quite obviously. So to fix that is actually quite simple. So if the player is in the enemy's view angle, then what we are going to do is we are going to cast a ray, ignoring the current enemy, of course, and we are going to we don't actually need to ignore this at all. So we are going to start the raycasting, and we are going to start it from our current position in our player's direction, and we are going to do a maximum of 32 units, and we are going to check the things. Now, if the thing that we hit, if it's player, which means that our ray directly hit the player, there was nothing between the player and the enemy, then that means that we can actually go ahead and do this. So what we are going to do is we are going to run make here, and now what you should be able to see is that the enemy does not detect me until I actually go in the enemy's view, and the enemy, there is nothing occluding between the enemy. So if I go here, you can see that the enemy starts hitting me, and that is working quite nicely. So anyways guys, this is going to be pretty much it for this video. In the next video we'll look at some steering behaviors and stuff, and that's going to be pretty interesting, so stay tuned for that. Make sure to like and subscribe as well so you don't miss that, and share this video with other people as well, and bye.